In Chapter 4, we're going to look at organization and trends of the elements on the periodic table. Two general vocab words that we should be familiar with are the difference between groups and periods. The groups are the vertical columns on the periodic table. The periods are the horizontal rows. With the elements on the periodic table today, there are 18 groups or 18 columns going up and down. There are 7 rows going across, or 7 periods. Now we also know that the rows or the periods represent the energy levels. So for example, when I say that carbon is an element in the second period, I mean that the electrons in carbon will occupy 2 energy levels. Interesting. So some of this will come back to haunt us. There are some trends with electron structures that we'll look at in terms of the groups or the vertical columns as well. I'm hoping that you're familiar with the terms metal, nonmetal, and metalloid. In general, most elements are metallic. All these guys are metals. A small fraction of elements are nonmetals. And most periodic tables will have this dark line written in kind of toward the right hand side, this little staircase. That's to separate the metals and the nonmetals. There are not a lot of nonmetals on the periodic table. There's even less elements that fall into this mysterious group called the metalloids. They're the elements that are right along this staircase. So what's the difference between a metal and a nonmetal and a metalloid? Well, some of this you're probably familiar with. In general, the nonmetals are just going to have the opposite properties of the metals. When I think about a metal, it should be shiny, which means it has luster. Metals are ductile and malleable. Terms that you may be familiar with. Ductile means that you can draw a metal into a thin wire. Malleable means that you can pound it into a thin sheet. I can do both with metals. I can have a thin sheet of copper. I can have copper in a wire. Metals are good conductors. Of both heat and electricity. Let's see, what else can we use to describe a metal? Most metals are solids. We could say most are solid. There's only one metal that's not. And I bet you're guessing it right now. Mercury. Mercury is the only metal that is not naturally a solid. There are no metals that are gases. They're usually pretty dense. You could say high density. They usually have a high boiling point. I think that gives us a good list. That gives us a good starting point. The words that come to my mind when I think of metals. Which means then that nonmetals are kind of the opposite. Nonmetals are not shiny. They don't have luster. In fact, I usually think of them as being pretty dull. Not that they're boring. They're not dull in that sense. There are some nonmetals that are very cool. But they're not shiny. They are not ductile and malleable, which I guess maybe the opposite, we could say they're brittle. If you try to draw Let's say sulfur. We'll look at some of these metals in class. Sulfur is kind of a brittle solid. It's not metallic. Sulfur will crack. If you try to draw it into a wire or into like a thin sheet, it's not ductile or malleable. They are not good conductors. We can say they are poor conductors. Poor conductors. They would not be good to conduct heat or electricity. There are some nonmetals that are solid. There are lots of them that are gas. There are a few that are liquids. So maybe we could say they can be all phases. Solid, liquid, or gas. I mean, if you look at the periodic table in the upper right-hand corner, that's where you're going to find nitrogen, oxygen, fluorine, chlorine, all your noble gases. A lot of non-metals are gases. There are some, like your carbon and phosphorus and sulfur. There are some that are solids. Bromine is the other element that naturally occurs in the liquid phase. Bromine and mercury. Bromine would be a liquid nonmetal. They have low density. We'll do a lab where we'll kind of measure the density of metals, nonmetals, and a metalloid. And then the opposite, their boiling points would be low. You can melt sulfur very easily. Just a Bunsen burner will melt your sulfur. You can't melt a metal with just a Bunsen burner. Okay, so these guys are easy. We got the properties of the metals. The nonmetals are just kind of the opposite. So then you got these mysterious metalloids. Now I get it says describe 4 properties. I could think of lots more than 4 properties for metals and nonmetals. I don't know. I mean, metalloids are these just kind of mysterious elements that seem to kind of fall between metals and nonmetals. I might just write that as kind of a blanket statement. Their properties are between metals and nonmetals. There are some metalloids. For example, we're going to look at silicone in class. Silicone is called a semiconductor. Does it conduct heat and electricity? To some extent. Not as good as something like copper. Most of them are solids. However, they're not as ductile and malleable as a true metal. You can have silicone in these real thin discs. But if you pound them too thin, they're going to crack. Some of them are shiny, some of them have a little bit of luster, but they usually have less density than a true metal. And again, their boiling points are kind of moderate. So maybe we'll just say that. Their properties are in between metals and nonmetals. So it's this small category of elements kind of right in between the metals and the nonmetals. We will look at one in the lab. We'll look at some silicone. Other little things that we'll mention about the periodic table. Early periodic tables did not look like our current periodic table. Here are some early periodic tables. They looked very different. This guy, John Newlands. John Newlands was one of the first guys to really organize the periodic table. He organized the elements in groups of 8, which is why here they're calling them in this periodic table the Newlands octaves. This was the periodic table of 1866. This was a long time ago. But he was kind of the first one to think about organizing the elements that they had known of at the time. So let's put Newlands periodic table. organized elements in groups of 8. And he tried to find 8 elements that seem to have some similar properties. Put them together, call them a group. Excellent. Why 8? I don't know. I mean, he seemed to find, like, well, here's about 8 elements that have approximately the same properties. Here's another 8. These guys are similar. But eventually, this pattern failed. Wait a second. Now I have a group of less than 8 elements that seem to have similar properties. Now, here's an element. I don't really know exactly where to put it. So now we get more sophisticated periodic tables. Dmitry Mendeleev is sometimes called the father of the modern periodic table. This is good. Mendeleev focused on organizing the elements by increasing atomic mass. Organized the elements by increasing atomic mass. Okay, so now this is a little bit more of a consistent trend. Instead of saying I just have to randomly find groups of 8 elements that have similar properties, the periodic table today really does go by increasing atomic mass. Excellent. And so now, for example, we could have elements, let's make up some masses. I'll say there's a mass of like 39.1. How about like 40.3? 47.9. And let's go like 50.4. Let's say these are atomic masses. Atomic mass is in units of 8 MUs. The periodic table really does increase by mass. Now the only problem is that the mass does not increase by the same increment from one element to the next. They do increase, but not steadily. So now here's the only problem that Mendeleev ran into. Sometimes he would look at his atomic masses and say, all right, so I go 39, 40. Whoa, here's this jump from about 40 to about 47, 48. And then I seem to kind of increase steadily again. When he saw these gaps in atomic masses, he left a hole on the periodic table. So for example, look at this.